how to sketch in this session. So I've taught you all the basics and you've learnt the hardest part was to find the x-intercept. From here now is putting it all together. Y-intercept, shape of the graph, and then transformations of a particular graph. You're putting it all together now so you can sketch. The thing with circular functions is one of the tedious things to sketch because you have many cycles depending on the domain and depending on the period. That's why it makes it hard to sketch. I want to show you a technique and you can draw it really nicely. You draw it really nice, but it takes up a lot of time. But over time you get better at it and it takes a bit faster, but still it's tedious. And it's probably the reason why since 2006 they haven't got students to sketch it in the end of year exams. But prior to that they used to get you to sketch circular functions. I haven't seen it for the past 10 years. They don't get you to sketch it, but they do get you to solve, which is what you're all able to do now. Okay, so that's good. You can solve. We're going to now show you how to sketch, right? We're going to call it, if you ever heard of Mr. Nolan, he talked a lot about the quarter cycles. I didn't really understand why he was teaching that way, but I figured out that it's actually probably easier to sketch using the quarter cycles, just to understand. It's probably tedious, but it makes it really nice. So I'm going to show you this thing that he calls the quarter cycles, right? And I'm going to show you the theory as to why it works as well and why it's sort of easy to understand. So we know in your graphing, we start off, let's start with a sine graph. Okay, I'm going to start off with a sine graph. Sine of x. And we know, this is what we know. We know the graph looks like this. Starting from 0, goes up, comes back down, comes back after one cycle. So that's your 0. That's your pi and 2 reaches a maximum of 1 at 90 degrees. At 180 degrees is back to 0. At 270 degrees, which is 3 pi and 2, it reaches negative 1. And this is my graph. Okay, so this is my sine graph. The special thing is, the reason why it's called quarter cycles is 0 to pi and 2, and then pi and 2 to pi, pi to 3 pi and 2, and 3 pi and 2 to 2 pi is actually your quarters. It's the quarter of a unit circle. If you think about it, if this is my unit circle, I'll draw it over here. If this is your unit circle, you're looking at these main points. That's all you're doing. You're going from 0 to pi and 2 to pi to 3 pi and 2 to 2 pi. And it's nice because these points are definite. They're in every single sine shape, there has to be these 4 main points. It has to have a maximum, minimum, and a baseline. The baseline is where the center is, right? So you got 1, negative 1, and the center is the average. Average is between 1 and negative 1, so it makes sense as 0. Yeah? So, how do you find the quarter cycles? Technically, these quarter cycles, which I'm going to do with a different color so you can see, you're really just finding this, and I'm just going to do dots. See, that's first quarter. This is the second quarter, third quarter, and fourth quarter. That splits it up into 4, right? You got your maximum, which I'll do a horizontal line here, and a horizontal line for the minimum. The nice thing is, these 4 points where they intersect, these are your main points. That's the quarter, 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 and quarter. Once you get those top, middle, bottom, you can actually sketch this infinitely. And I can give you any graph. So the aim today is I'm going to show you how to sketch what we've done yesterday and how to solve, and then how to move this graph left and right and still use the quarter cycles so you can sketch it nicely. Okay? So how do you get this quarter cycle? Notice quarter cycle means that in the cycle, which is 2 pi, normally it's 2 pi, you divide that by 4. So whatever the period is, divide that by 4 and you get your quarter cycles. In our case here, our period is 2 pi. So 2 pi, so right here, period equals to 2 pi. So my quarter cycle would be 2 pi, divide that by 4. And that gives me pi and 2. So what does that mean? It just means that every pi and 2, I have a quarter cycle. So this is pi and 2 plus another pi and 2 gives me pi. Plus another pi and 2 gives me 3 pi and 2. 3 pi and 2 plus another pi and 2 gives me 2 pi. This is my every quarter cycle. Okay? That's the start, right? And then what I'm going to show you underneath all this is now transformations, how I've taught you. Quadratics, cubics, exponentials, logs, everything I've taught you and how to move a graph up, down, left, right, thin, wide, reflect, is all the same. Okay, so everything's still the same. We're going to use that to then learn how to sketch the things you did yesterday. Because yesterday you found the hardest part was to find the x-intercepts. Now it's drawing it. Yeah, drawing is just, it's easy. You follow this, it's tedious, but it's easy, right? Anyone not understanding the quarter cycle so far?
What is the period?
The period, so how I knew, the period is basically depending on, yeah, because that shrinks it.
But can you have a period, what happens if it's like x minus something? Is it the period or not?
The period is still the value, the coefficient times x.
So if there's no coefficient, there's no, like it's still
Yeah, exactly.
Because after yesterday's session, the minus 1.
Then that moves it left and right, but it doesn't change the period. It doesn't change the width of it. See, I can take this graph. It's still 0 to 2 pi, but I can move it to the right, and it's still 0 to pi. Yeah, it'll still be 2 pi.
That plus x plus 1.
X plus 1, then it just moves it up. So, but the distance between it is still the same. See
So
there?
I mean, if it's sine x plus 1.
Yeah, plus 1 will make it to the left by 1.
And if it's a plus 1 on the outside of the bracket,
It'll move it up, but the width is still the same. So the only time it changes it is if that's not 1. If that was 2x, if that was 3x. See, if it was 2x, it shrinks it.
that's just the.
Yes, exactly, the dilation. Yeah, and that's what we're interested in. Whatever the period is, we divide it by 4, that gives us our quarter cycles. Okay? Now let's revise on our functions. So we've got y equals 2, and the general function I gave you was a bx plus c plus d. All of this still is the same. Bx plus c tells you if it moves left or right. Okay? So I'm going to write it here again just to remind you all. This tells me it moves left or right. D still tells you up or down. A tells you the vertical stretch, which we called it the amplitude. Okay, so A tells you the amplitude, so thin or wide. Okay, so I'll write here thin or wide, and reflection as well. And that's the same with B. B is still a reflection. Same thing as what you've done previously. Okay? So all of that's still the same. The thing is, B determines the number of, how thin you stretch it. So if it's 2x, halving it. 3x gets thinner. Yeah. This one is the x, as in reflections in the x-axis, but it affects your y values. Affects your y values, hence you reflect in the x-axis. This affects your x values, so it reflects in the y-axis. So I'll write here reflection in y-axis, and this is reflection in x-axis. Okay, we're going to use this understanding of how I taught you for transformations, and then we're going to use what I talked about today about quarter cycles, and we're going to try to sketch one of the graphs that we have. Okay, and hopefully it makes a lot of sense. Well, I'll do about 2 or 3 examples so you feel confident, and I'm going to get you to do a few this session. Okay, we're going back to 14H. Technically from G all the way to J is all sketching. You can sketch all of that, but I like to start at J because it has everything together. It has left, right, up, down, dilation, so you don't have to do the other ones. Okay, you can just focus on J. You get that correct, then you're mint. All right? All good? All right. Let's have a look now. Let's do an example. I'm going to do an example. Let's go to 14J. Here we go. Let's have a 14J. I'm going to do, let's do something that has everything all together. Let's do, this doesn't have a left to right. I'll do this one, E. Yeah, E has them all. So I'll do E. Okay? Let's do E together. Here we go, E. So 2E has everything together. Here we got Y equals to 2 cos 2x minus pi on 3 minus 1. And it's between so x is an element of negative pi to 2 pi. Okay. Here we go. This is what we're going to do. We're going to try to sketch this graph. So now you've learnt, I asked you in yesterday's section, I taught you how to find the x-intercepts for this one, right? That was the hardest part. Now it's just sketching. So sketching, I said that we're going to have to find the quartercycles. That's our goal. We're going to try to find our quartercycles. But the only way to find our quartercycles is if you find your period first. Okay? So let's have a look at things we know. We know 2. What does 2 tell me again? What does the 2 tell me? Amplitude. That 2 tells me amplitude. What is amplitude? Amplitude just tells you the maximum and the minimum value. That's what it tells you. It tells you how far you go up and how far you stretch down. Because in a sine or a cosine graph, you can stretch it up and stretch it down. Yeah? And usually has a maximum 1 and a minimum of -1. But now you're stretching it by a factor of 2. It's maximum 2 and -2. Okay, so try to picture that. I'm going to draw an axis like that. I'm going to say, all right, it should be stretching up to 2 and bottom to -2. A cos graph, we know that it looks like this. Previously, I showed you that it looks like that. Okay, so this is what roughly the graph looks like. Don't sketch this, okay? I'm just trying to show you.
So don't do any.
Don't do this part. Just write amplitude there. Okay. What I'm trying to describe is that 2 just tells me it's maximum. What I haven't done is I haven't looked at what happens to the transformations. This tells me I'm moving to the right pi and 3. That tells me I'm moving down by 1. If you forgot how I understood this, let the insides equal to 0, and I told you if you solve for x, it tells you whether it moves left or right. Yeah? So if I actually try to solve this, 2 bracket x minus pi and 3 equal to 0, x minus pi and 3 equals 0, divide both sides by 2, and then x equals pi and 3. This tells me that I'm moving to the right by pi and 3, because that's positive.
Oh, yes.
Okay, so I'm just looking at the transformations. That's stretch vertically, factor of 2, so I've stretched it vertically to factor of 2, -2. This tells me left or right. How do you know? The technique I've taught you always is to let the inside equal to 0. Solve for x. If it's positive, it moves right. If it's negative, it moves left. And finally, the -1 tells you what? What does -1 tell you again? Goes down 1. Okay? So, this is what I want you to know in your head so far. So think of this. This is your normal graph. This is your 2 cos of x. What you now have is you're shifting it down by 1. And not only that, you're also shifting it to the right by pi and 3.
So does that mean the amplitude's now 1 to -3?
Good. Okay, so that's the first thing. So how do we start sketching? This is what I want you to understand. If this is 2, -2, if I shift it down by 1, obviously 2, this coordinate here would now become 1. This coordinate at -2 should now come down to a minimum of -3, because I said shift down by 1. True? So now, this should be my maximum. My maximum should be, wait, I'm going to draw this again. My maximum should be 1, and my minimum should be -3. Wow. But logically, where should my middle be? See, my middle before was at 0. It was -2 to 2. Now it's -1. So, the reason why I'm emphasizing this, because then you can see where the vertical top end, low end is. Because you're going to stay within that. When you draw your graph, it's going to stay within that. Okay, because we know our maximum, we know how much you've translated up and down. So we know it has to be between these lines here. So I'm just doing these dots here. And that's the first step. See, that's the first step. Okay, now this is easy because we know it has to go up, middle, bottom. Back to middle, back up. That's how we know, and that's how we sketch it really nicely. Okay? The only thing I'm missing now is, where are my quartercycles? See, once you get your quartercycles, you can just plot top, bottom, low. Yeah? Because you know the graph looks like this.
Does that mean we solve the x-intercept?
No, that x-intercept is always last. Okay, you solve that last. This is just trying to get a visual idea of what the graph will look like. You need a quartercycle. So quarter cycle now is where is it on the x-axis, right? And this is easy because you knew where the first coordinate was. This is where the first coordinate was. True? Because it started off here and you shifted down by 1. So this is where the first coordinate is.
What about move
Yes. So you now move to the right by pi and 3. So this one will move across pi and 3. True? Yeah? Because this is my top, and that's where my first coordinate is, and I'm just moving it across by pi and 3. So this is how I normally start it. I started off by saying, all right, so moved across to pi and 3 over here now. So that's where it is. That's where the start is. Oh. Okay? I know it's here. Now, what I need is a quarter cycle. Every quarter cycle from here, it will tell me where the next point is. So, let's take a step out. To find your quarter cycle, you need your period. In order to get your period, it's dependent on what you're multiplying, the b value. Multiply to x. Now, the number that's multiplied to x right now is 2. So, my period is equal to 2 pi divided by 2, which is pi. Okay? So that means this is my now, in order to do one cycle, it takes 1 pi. But if I want to find a quarter cycle, I have to divide that by 4. True? So, quarter cycle. Here we go, quarter cycle. Sorry guys, we just try to focus on this part because this is the main part. This is the quarter cycle that I'm trying to introduce in, yeah? So, we understood maximum, minimum, shifted down by 1. So we've got the top ends, we've got the middle end. Now we need the starting point. Starting point we said move to the right by pi and 3. So I know it's moved across. That's my first point. You choose any first point you want. But I like to choose the very left end point of the graph. And now I know I just need every quarter cycle. Now if you think about it, from pi and 3, if I add another pi and 4, that should give me my first quarter. True? Yeah? Because I'm just trying to say...
Quarter cycle this way.
In a quarter cycle... I'll go back to the notes I did before. So, look at quarter cycles. What were quarter cycles again? 0. Pi on 2. Pi. 3 pi on 2. Yeah? We've done the y's. We're just missing 0. Pi on 2. Pi, 3 pi and 2 pi. Yeah? So let's go back. What are we missing? We are just missing pi and 3. We need that next quarter cycle. So the next quarter cycle, we figured out it's an extra pi and 4. So this is where it gets tricky. So pi and 3, to get to the next quarter cycle, it should be plus pi and 4, right? Which is 7 pi on 12. So that means, just bear with me right here, this is where it gets confusing. So you know that the next part should be 7 pi on 12, true? But think about how much did you add on? So you added on pi on 4. That's what you did. You added on pi and 3, you add pi and 4, right? But think about that distance. If I want to add again to get to the next quarter cycle, and to get to the next quarter cycle, you have to add pi and 4 again, true? Yeah. And here's the thing. We want to make it nice. And so 7 pi on 12 plus pi on... Just bear with me. Yeah? Stick with this. You're adding pi and 4. Yeah? 7 pi and 12, to get to the next one, you have to add pi and 4. But there's a pattern. So check this out. 12 and 4, I can change that to a 3, which means this could be 12 and this is 3. See, that's still pi and 4. That's still the same thing. But why did I like this? Because this tells me now to get, if this is 7 pi and 12, to get to the next one, I need to only add 3 pi and 12. So that means I know, okay, well that makes this 10 pi and 12. If I want to get to the next cycle, I add another 13 pi on 12. If I want to get to the next quarter cycle, I add another 3, 16 pi and 12. If I want to get to the next quarter cycle, 16 plus another 3 gives me 19 pi and 12. If I want to get to the next quarter cycle, you do the same thing again and you say 22 pi on 12. But remember, how much are you adding? You want to get up to 2 pi. 2 pi is equivalent to 24 out of 12. So I'm still not there yet. To get another 3, I would have to add the next quarter cycle would be 25 pi on 12, which is out of my domain. So I know my graph is going to finish before I even get there. Now here's the thing, why did I want these points? And I'll show you. I'm going to do blue lines so you can see. I'm going to do these vertical lines. Look, later on you're not going to have to do these vertical lines. I'm just doing it so you can see what I'm doing. Now watch this. The reason why this is so nice is because every quarter cycle it goes top to the middle to the bottom to the top to the middle back to the top. So wherever they intersect, so right there, I already know. This is what I know. This is my cost graph.
So should we stop drawing this graph thing? You said it's a sketch.
Oh yeah, yeah. Oh yes, yes. I'll do another example. You can copy that one. I'm just trying to describe so you understand the process. But see what I'm doing? I'm just following the same thing. Now I know this is my cost graph. See, the cost graph goes top. That's my next quarter cycle. 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 So I'm going to just put the dots in so you can see. That's my second, third, fourth, and final. And I just follow that. See, I've just followed. Once I've got all my quarter cycles, it's so easy because I can just carry on and follow the graph. Whoops. And, well, wait. It's hard to draw on this. Let me do it. Okay, so from the top, down, all the way up, down, and then...
It's like a roller coaster.
Now, what I know is this doesn't reach to the middle because that's 25 pi and 12. So 24 pi must be somewhere here. I would not even reach -1 because -1 was the center. So I'm somewhere here. I would stop. Now I know this is roughly what it looks like. So if I want to sketch the entire graph, it's so easy now because I know it's every 3 pi on 12. See, if this is 7 pi on 12, this must be 4 pi on 12. Which makes it pi on 3. So 4 pi on 12, take another 3 pi on 12, makes it 1 pi on 12. So I know my next quarter cycle is at 1 pi on 12, which should be here. Then if I want to find the next one, if that's pi on 12, subtract 3. So 1 take away 3 would be -2. So -2 pi on 12. So I know, all right, -2 pi on 12, subtract another 3, -5 pi on 12, subtract another 3, -8 pi on 12, subtract another 3, -11 pi on 12, subtract another 3, and you get to -14 pi on 12. Are you confused here?
Yeah, why is it going negative?
Oh,
the domain.
Because the domain that we started off, we said -pi to 2 pi. Yeah, I've started with the first point, and now I want to expand it. But once you've got the quarter cycle, you can just keep repeating, and it's so easy to sketch because you've got just this same pattern, quarter cycle, and so you can just now follow. You're like, all right, well that's the quarter cycle here to the next quarter cycle to the next quarter cycle. So you just follow it. You're like, all right, so it goes top, middle, bottom, middle, top, middle, and then you probably finish somewhere there. See what I'm doing there? So I'm just going top, middle, bottom, middle, top. So wherever every quarter cycle, which where it intersects, quarter. So if I finally follow it, see what I'm doing? See what I'm doing? So the quarter cycle is the most important part. And the quarter cycle, once you get that quarter cycle, once you know how much you're adding on, it's not pi and 4. See, pi and 4 was tricky because you started with pi and 3. It's this last part, that 7 pi and 12. This is the key part here. How you change that pi and 4 to know how much you're adding on makes it so much easier. So much, and it looks nicer. See, I did a really rough sketch here, but you can see that it's very methodical. And you can do that for every single graph. Doesn't matter if I have up, down, left, right. I've got all combinations here. All of them. So you can do it without the -1. In fact, the easiest ones to sketch are the ones where you don't have to move left and right. The left and right is what makes it harder. But if you have 2, 3, it doesn't matter what these numbers are. It doesn't matter what that number is. It doesn't matter what B is. It's when you move the graph left and right that makes it hard. Because you're shifting where the first point is. But other than that, everything else is really easy to sketch. Once you get the quarter cycles. How do we feel? Another example? I'll do one more? Yeah? One more. Let's do one more.
Can I ask why? How do you know when it's going to finish? Like when it finishes before 1?
Because I knew that this was the quarter-cycle here.
Yep.
Then, so if that's middle, it comes down to the bottom, the very bottom. And then the next quarter-cycle means I have to go back to the middle. So the middle is -1. So if that's your middle line, then 20, 24, pi and 12 has to be somewhere before it. So as long as you just draw the curve back up. You don't know where, but you're going to have to find that endpoint later on. I'm just trying to get you to get the curve first. Endpoints are easy. Sub in 2 pi in and you find out your y value. Sub in negative pi should both be the same. Should both be the same because they both get cut off at the same level. If that makes any sense. Yeah? Okay? So you can find out endpoints easily. X-intercept you all learned how to do now. Y-intercept's the easiest one. So you let x equal 0 and you can solve it. So you're there. See, graphing is really easy. The hardest one is finding x-intercepts. That's the hardest ones to find. Okay? Let's do another example. Let's do another one. I'll do a sine graph. Let's do f. Okay, let's do f. I'm going to do f. All right, let's try this one. Same goal. Same goal. Let's start off with what we know. 2. What does this 2 tell me? What does this 2 tell me here? That's my amplitude. The amplitude is key because it tells you how far up and how far down you have. That's your maximum minimum, yeah? So this is your amplitude, is 2. But because you're shifting the graph up by 1, so this is up 1. So that means your maximum value and your minimum value now changes to what? What's your maximum and minimum? 3 and -1. Because 2 tells you you're meant to have 2 and -2, but because you add 1, everything shifts up by 1. So now your minimum should be at -1 and it should be at 3. Does that make sense? Now you're going to copy this one. Okay, so this is how I would sketch it. I would start off by doing a vertical axis. Okay? This is how I would do it. I always get the top ends and the bottom ends first. So I'd say amplitude. Where'd that come from? Alright. Yes. Amplitude 2 up by 1. So I already know it was -2 to 2 up by 1 makes it -1 and 3. But then where is my middle line then? If this is -1 and 3, where's the middle? 1. Okay, you shifted up by 1. So, there we go. This is nice because I now know this is my top line. Remember, you don't have to draw these lines. I'm just drawing it so you understand. So I've got top, and I'm going to draw a middle. So here we go. We've got the middle. Okay, we've got those dots. Middle. The only thing you need now is the starting point. See, this is a sine curve. It's a sine curve, and we know sine graphs starts at 0. It looks like this. So you're going to use that first point. Now, using that first point at 0, you're reading this now. What am I doing in this bracket here? Am I moving left or right? What am I doing? Left by pi on 6. Okay, so if you solve for that, you know it's left by pi on 6. So I know I'm going to use a different color here. Red. That means I move to the left pi on 6. So I'm going to do this. I call that pi on 6. That's my first coordinate. So it was at the center, and I move it to the left by pi on 6. Your only next thing you need now is where are my quarter-cycles? Because once you know where the quarter-cycles are, you just put the intersections. Yeah? That's how you do it. So we know this is a positive graph, that's a positive sine graph, so I know it's got to go up and back down, right? So I need my quarter-cycles. How to get your quarter-cycles? Find your period. Oh yeah, you're right. Thank you. Period. What is my period equal to? Pi, because it's x is being multiplied to the value of 2. So I know it's 2 pi on 2 period is pi. Quartercycles. Yeah, you know, like the number in front of x tells you how much to shrink it. So if it's 2, you halve it. Yeah, you halve the. So you remember when we were doing these? See how that one stays as 2 pi? It means it's still 2 pi. When you put a 2 there, it means you shrink it. So if you shrink it, you take a 2 pi divided by 2. So the period for this graph is 2 pi divided by 2. The period for this graph is 2 pi divided by 3. Is that, yeah? So that just means how long does it take to make one cycle? It takes 2 pi and 3. Okay, or 2 pi to make one cycle. So, let's go back to this. Here we go. Quarter cycles. We know the period is now pi. We want to find a quarter cycle. Quarter cycle is take your period divided by 4. So I now have, boys, settle down. We now have pi on 4, and that's how much I need to get to the next quarter cycle. But that's not the key part, you see. The key part is, this is a pi on 6. We know we're adding by pi on 4, so we're going to work it out. Pi on 6, negative pi on 6, plus pi on 4 will tell me the next quarter cycle in this direction. So I'm adding by pi on 4. So you got to work that out. So we're going to work this out. Negative pi on 6 plus pi on 4 is technically, you can do your cross method if you like. That's what, 24. That's negative 4 pi plus 6 pi. That gives you what, 2 pi on 24, which is the same thing as saying pi on 12. Yeah, I'm just doing fractions right now. So that's just fractions, yeah? 6 times 4 is 24. 4 times negative pi is negative 4 pi. 6 times pi is 6 pi. Negative 4 plus 6, positive 2. Yeah? 2 out of 24 is pi on 12. So now I know I need to move to the next point, and that's pi on 12. So the pi on 12 is somewhere over here. Let's just say it's here. I don't know where it actually really is, but let's say pi on 12 is there. Right? That's my next quarter cycle. So I'm drawing all my quarter cycles. Here we go. That's my quarter cycle. That's my first one. To find the second one, that's the key part. Your quarter cycle is pi on 12, and we want to find the next one. So I know it was from the start, it goes to, oh sorry, it moves to the left. That's where I'm starting. Okay, because remember, it's not only moving left but going up. Okay? Yeah, but remember it went up. Yeah, so left and up. So this is my first coordinate for the point. My next quarter cycle has to be the maximum. We went from the middle to the maximum. So my maximum here, it has to be at pi on 12. But this is the key. We haven't figured out every quarter cycle yet. I don't know how many are moving. This is the key step. Pi on 12. No, not pi on 12. Plus, what's my quarter cycle? Pi on 4. You see I wrote here, quarter cycles, we figured out was pi on 4. I'm just adding pi on 4 each time. So the first one I did was I took negative pi on 6 plus pi on 4, gives me this quarter cycle. To get the next quarter cycle, it's pi on 12 plus pi on 4. But I want you to find a pattern. There's always going to be a pattern. So here, pi on 12 plus pi on 4, I know that's the same thing as saying, pi on, they screwed up. Here we go. Pi on 12 plus 3 pi on 4. I mean 3 pi on 12. Okay? And that's the key. This is the key part that allows you to sketch it much easier. So you went through all that to get here. This is the key step because now you know from pi on 12 it's really just every extra 3 pi on 12. So I know if this is 1, the next one has to be 4 pi on 12. The next one has to be 7 pi on 12. The next one has to be 10 pi on 12. The next one has to be 13 pi on 12. The next one has to be 16, and then 19, and then 20, 22, and then finally 25 pi on 12. See what I'm doing there? Okay, once you do that, once the key part was finding how many extra you have to add, because once you know how many extra, it's so easy to sketch. You see, you've got all your vertical axes now. So if I put all my vertical axes, here we go. Vertical axes, vertical, vertical, vertical. It's easy now. You've got all your points. You started off here, left by pi on 6, up by 1, That's where you start. Top, middle, bottom, middle, top. You just follow. So if I just follow that, it now goes here, middle, to the bottom, to the top. I mean to the middle, to the top, to the middle, to the bottom, and then to the middle, to the... And as you can see, 25 pi and 12, that's almost 2 pi. So I know I must finish before I even reach the top. So it has to be somewhere in between here to make 24 pi on 12, which is 2 pi. But this is nice. See, once you put all the dots, it's easy to sketch because you just follow it. Oh. Yeah. But I'm just trying to show you, can you see the pattern? The pattern that I'm doing, once you get the dots, it's easy. Yeah? And that's the hard part. What's the hardest part? It was just trying to find how many you add extra. But now that you know how much you add extra, you can work backwards. See, if that was negative pi on 6, subtract another 3. Subtract another 3, that's now negative 4 pi on... Actually, no, that's wrong. That's negative 2 pi on 12. That's negative 5 pi on 12. Then negative 8 pi on 12. And then negative 11 pi on 12. And then finally negative 14 pi on 12. Which is more than negative 1 pi. Okay, so then you just follow your vertical axes. Vertical, vertical, vertical. And you see, just follow it. Middle, bottom, middle, top, middle. Yeah, so just follow it. Bottom, middle, top. And because this is negative 11 pi already, I'm meant to finish before I even reach 14 pi and 12, because it has to be negative pi. That's what my domain was, negative pi. So negative 11, the next part is negative 12. So I must finish somewhere before that. And so if I put it all together, graph, and it looks nice. You don't need to draw the dots. See, if you don't draw the dots, this looks nice. Right? You can find x-intercepts. That's what you've been doing for the past 3 sessions. Y-intercepts is easy. Endpoints are easy. Sub in negative pi and 2 pi, you'll find the endpoints. And voila. Yes, you do. That's how you sketch a perfect graph. Okay. So negative 2 pi is at this point here. If you sub it in, it tells you what the y coordinate is. Yeah, because x is equal to 2 pi. X is equal to negative 2 and negative pi. So this is the x-axis. Yeah. So endpoints. It's when x equals negative pi, or when x equals to 2 pi. You want to find the y coordinates. Y equals to 2 sine of 2 times 2 pi plus pi and 6. Work out this value here. So at 2 pi, we can work out this value. It's 2 sine of 2 pi plus pi and 6. Thank you. Add 1. This makes it what? 4 pi plus pi on 3 plus 1. And you can now work out using your symmetry properties. 4 pi in a unit circle. Think about a unit circle. 4 pi.
Why did you put pi on 3 for?
Because 2 times 2 pi is 4. 2 times pi and 6 is pi and 3. Yeah. I'll do a line like that. Okay. And now you can work out what sine of this is. This is what you've been doing exercise 4F. 4F, 4 pi plus pi and 3 means it's in this quadrant. Sine is positive. Sine of pi and 3 is root 3 on 2. Root 3 on 2 times 2 plus 1. Yeah? Wait, no? So we're confused with this. Sine of 4 pi plus pi and 3. Exercise 4F, the very first time I taught you exact values. So look.
Do we ignore pi, 4 pi, or?
No. So
It's just pi and 3.
Yeah.
Which is that one. Does that mean we just ignore the pi?
No. Remember, you got to use this 4 pi to know where you are in the unit circle. So 4 pi, sitting here. True.
But I mean, it's not to work out the.
No, but you need to know if it's positive or negative. That's what this is for. Because it matters if I said if this was 5 pi and minus. If I said minus pi and 3. So 5 pi minus pi and 3 would be here. Yes, but then if I said plus, negative. Yeah, so it's still root 3 on 2, but that tells you where you are in the unit circle. Yeah? Exercise 4F. 14F. Because I haven't finished. I was trying to tell you. So, that's your endpoint. So when x is 2 pi, that's my y value. That's my endpoint. Yeah? Alright. I spent quite a bit trying to explain how to sketch these graphs. Really, you just got to practice finding that quarter pi. Yeah? Everything in between are the skills that I try to teach you. Yeah? Prerequisites on how to solve. Yes, Jamal? Except for one thing. So yes, you got everything correct, except for maximum minimums. You don't need to label that. Okay. So you need everything else except for minimum and maximum because there's just too many of them. Okay, so when you sketch a circular function, what do you need? X-intercepts, y-intercepts, endpoints, and the correct shape. Okay, you don't need the maximum minimums, you don't need to label that. Okay, that's all you need. An endpoint. And the shape, sorry, and the shape of the graph. Okay, that's why it's the tedious thing to sketch, but it is easy to do. Yes, that's it.
No, I was just looking at my graph of numbers on my quartercycles and then my intercepts and so much.
It's a lot of work. It's a lot of work.
Adding the x-intercepts here.
Yeah, you're right. That's why I like to do the graph first and then find the x-intercepts later and I just label it. So I would have done this and then I would have labeled the x-intercepts afterwards. So I do that last. And that's the hardest skill to be able to find x-intercepts. The sketching is easy, quartercycles. Alright, just to get you guys moving on to them, try question 3, try sketching them, or just going back to 14J, if you like it easier, go back to these values, where you don't have left, right, you only got up and a dilation. These are easier to sketch, it's only 0 to 2 pi. It's when you do question 3, if you can do question 3, like without having any troubles and you check the back of the answer is correct, you're min. That's it. You see, we didn't have to do 4H, 4I because we just jumped to 4J and you can apply all your knowledge. So you got your basic skills. Solving x-intercepts, now graphing. That's what we're going to be working on, graphing. Okay? So on Monday, when I see you again, that's what we're going to be doing. We're going to make sure that you can sketch these graphs. No matter what the name, no matter what I give you here. Okay, that's what I want you to work with. And that's it for today's session. And we're just about to finish as well. I'm gonna end this video.